Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again after months of spouting gibberish. The spaceship left the solar system in 2012 and is currently more than 15 billion miles from Earth.
Voyager 1 has surprised us once again, more than 15 billion miles from Earth. At the very edge of our solar system, it has stumbled on something that no one expected and ordered. Stable magnetic field unlike anything seen before. A structure so precise and geometric, it challenges decades of assumptions about how the boundary of our solar system works. Before I break this down, do me a quick favor. If you enjoy exploring discoveries like this, subscribe right now. That way, you'll always stay connected to these cosmic mysteries as soon as they unfold. Voyager 1 was launched in 1977 at a time when the internet didn't exist. Cell phones were science fiction, and humanity's reach into the solar system had barely touched Mars. It was part of the legendary Voyager program, to probes built to take advantage of a rare planetary alignment that happens only once every 176 years. Voyager 1 and its twin, Voyager 2, used gravitational assists for Jupiter and Saturn to slingshot themselves outward, stealing momentum from the giant planets. To gain speed toward the edge of the solar system. By 2012, Voyager 1 became the first human-made object to cross into interstellar space, piercing through the heliopause, the invisible bubble created by the solar wind. This is the frontier, the place where the sun's influence fades and the galactic environment begins. For decades, we imagined this boundary as chaotic, stormy, unpredictable, but Voyager 1's most recent data suggests something radically different. For months, Voyager transmitted garbled signals. Many thought this was the beginning of the end for the spacecraft, whose instruments run on a power source that's been dwindling for decades. Then, in 2025, the probe's readings stabilized, and what emerged was stunning. Instead of the chaotic plasma turbulence predicted by theory, Voyager detected a highly ordered magnetic field structured like a lattice, pulsing with rhythmic oscillations. Imagine standing at the shore of an ocean expecting crashing waves, only to find a still, glassy surface etched with perfect, repeating ripples. That's what Voyager found. The magnetic field wasn't random, it was geometric. Field lines aligned into stable, coherent patterns, inconsistent with what plasma physics predicts at such scales. Even more bizarre, Voyager's plasma wave detector picked up low-frequency, modulated emissions in sync with the structured field. These weren't linked to solar flares or coronal mass ejections. They appeared to rise from the boundary itself. Cosmic rays told another part of the story. These high-energy particles, which usually rush in from interstellar space, behaved strangely when they hit the boundary. Voyager detected abrupt discontinuities. Some particles filtered out, others passing cleanly, as if the field itself acted like a cosmic gatekeeper. Scientists initially feared this might be an error. After all, Voyager 1 is nearly 50 years old, operating far beyond its intended lifespan. But when they compared the data with Voyager 2's trajectory and readings, the phenomenon checked out. This wasn't noise. This wasn't an artifact of aging instruments. This was real. What Voyager found forces us to rethink the very architecture of the solar system. The heliopause is not just a chaotic shield, it might be a structured membrane, a threshold where order emerges out of apparent randomness. So what could cause it? One possibility is dark matter influence. Cosmology tells us that dark matter forms massive filaments throughout the universe, an invisible skeleton shaping the galaxies themselves. If such filaments thread through or near our solar neighborhood, they could impose unseen order on magnetic fields. It's a radical idea, but one that some astrophysicists are beginning to entertain. Another theory is interstellar field interference. The sun is not isolated, it swims through the galactic medium, bathed in broader magnetic currents. At the heliopause, our sun's influence may resonate with these galactic fields, creating interference patterns that look structured instead of chaotic. Others suggest a form of plasma resonance on interstellar scales. In this model, the boundary acts like a drum head, vibrating at certain frequencies, producing standing waves of magnetism that organize themselves into patterns. If true, this discovery could have profound technological applications, hinting at natural highways for communication signals or even propulsion systems. And then comes the controversial idea: artificial structure. Could an advanced civilization have engineered the solar system's boundary, or at least manipulated its properties to us? It sounds like science fiction, but some researchers point out that if you wanted to create a detectable signature, leaving an ordered pattern at the edge of a star system would be an elegant way to do it. Voyager, in that case, would have stumbled onto a message not meant for us, but for anyone reaching interstellar space. Regardless of its cause, the implications are enormous. Scientifically, this redefines how we see the solar system. Instead of ending in chaos, it seems to end in order. That means cosmic rays, solar wind, and interstellar matter interact in ways we never accounted for. This could reshape our understanding of how stars and planets evolve, how radiation travels, even how life itself spreads across galaxies. Technologically, it raises new questions about how we'll build the next generation of spacecraft. If interstellar travel becomes a reality, probes and cruise ships will have to pass through these boundaries. Will structured magnetic fields affect navigation, shielding, or communication? Could we even harness them using the patterns as navigational markers, or their resonance as a kind of natural engine? Philosophically, the discovery is even more profound. We've always imagined the edge of the solar system as a vague, invisible border. Now, it looks like a design threshold, a membrane between home and the wider galaxy. Whether natural or not, it makes us question if the universe is more intentional than we believed. Are these structures accidents of physics, or do they point toward some deeper architecture of reality? There's also an astrobiological angle. If magnetic boundaries regulate the flow of radiation and particles, they could play a role in how organic molecules spread between stars. They might shield habitable planets from deadly cosmic rays, or conversely, act as highways for life-bearing molecules drifting across the galaxy. To put this in context, Voyager 1's discovery is not the first time humanity has faced a boundary. That seemed more mysterious than expected. When we discovered the Van Allen radiation belts around Earth, we learned our own planet is wrapped in protective layers that deflect cosmic radiation. When we studied Jupiter's magnetosphere, we found a magnetic environment so large it dwarfs the planet itself. Now, at the very edge of our system, Voyager is telling us that the sun's influence ends not with a messy fade, but with order structured, elegant, and possibly meaningful. Future missions will build on this. Scientists are already talking about probes designed specifically for interstellar travel, capable of mapping these boundaries with precision. NASA's interstellar probe concept, still in early stages, envisions a spacecraft launched in the 2030s or 2040s, designed to reach 1,000 astronomical units from Earth 5 times farther than Voyager. With modern instruments, it could confirm and expand on what Voyager 1 has just hinted at. And beyond probes, there's the dream of human interstellar travel. If one day we send cruise ships beyond the solar system, understanding these structures won't be optional, it will be essential. These magnetic membranes might be the first obstacle every civilization faces with leaving its home star. The public reaction has been electric. People around the world are speculating about what this discovery means. Are we seeing dark matter in action, or plasma physics at a new scale? Are we brushing up against signs of intelligence, or is the universe simply stranger than we ever imagined? Voyager has reminded us that even at the edge of known space, with a spacecraft built using 1970s technology, discovery is alive and well. As scientists pore over every byte of data, the larger truth is undeniable. The solar system is not just a collection of planets and moons orbiting a star. It is a dynamic, structured system with boundaries as mysterious and complex as its core. And Voyager, still whispering across the void after nearly 50 years, is showing us those boundaries in ways we never dreamed. So what do you think? Is this the fingerprint of dark matter, the resonance of plasma waves, or something more? Could this be nature's architecture or someone's design? Whatever the answer, Voyager has given us one of its greatest gifts yet. It has shown us that even at the farthest reaches of human exploration, the universe holds patterns of order waiting to be discovered. And if you want to keep traveling into these mysteries with me, make sure you subscribe now. Together, we'll keep unraveling the secrets of the cosmos, one story at a time.